So we also partnered with the Bethel BUS mentorship.
Jacob, go a little closer, sorry, so there you go, perfect. You're good, you're good. Yeah.
I'm Davey. I'm Davey. I forgot about this part.
So a little overview, we'll go over our client, the initial problem, how we approach the data, our results. We'll go through recommendations for Linda and Bethel BUS, and then the problems we encounter. So our client is Bethel BUS, and their mentorship program that connects alumni with current Bethel students of majors like business, communication, math, and computer science. And the mastermind kind of behind it all is Linda Goodwin. She is the mentorship program director, so she does all the matches by hand. So the initial problem is that Linda is working her magic and matching all of these pairings by hand, which is definitely not efficient or scalable with all the technology that's out there. It's not scalable either if Bethel BUS wants to increase their numbers. It'll just take a lot more time, and then it's not really optimizing, or it's hard to evaluate. So like without data, we don't know if the matches are really successful or not. So our task was to help Linda automate the matching process and trying to figure out what leads to a successful match.
So looking at how we approach the data, the first thing we had to decide was what is our Y hat, what are we trying to find? We found the three fields that are most important for us were first, are they eligible to reapply for Bethel BUS? Are they graduating? Things like that would make them uneligible. Second thing would be, are they choosing to be in the program again? And then the third thing would be, if they are in the program, are they staying with their same mentor? So it's kind of the three things we decided, so we'll go in two different approaches, with the first one being, are they staying with the program, and the second one being, are they with their mentor? For number two, continuous variables, GPA was a big one for us. We found that continuous variables played a bigger role than anything else, so you'll see that one in our data later. Nominal variables being those drop-down fields, things like what is the mentee's major, and then maybe for mentor, what kind of career are they in, things like that. And then the last thing, open field, we actually had these in there, but we got rid of them because they kind of just messed up our findings, and we didn't have enough data to even get into that. So that's something actually interesting seeing their project, because they got into those open fields, and chat is able to look at things like that, versus ours is very much a simple math-based model that didn't even get into that at all. So we'll kind of see the differences with that. So something to note is this is a 1 year time period. We were missing data on either the mentor or the mentee side. It's kind of an interesting problem because we have to have the before the mentorship, their application data for the mentors and the mentees. Then you have to have the mentorship year, who they're with. Then you need the post-mentorship interview that shows the results, that like our Y hat. So did they stay with it? How did they go? Things like that. So we kind of need a 3-year period just for this 1 year. So we were either missing, it was always like we were missing data on one side or the other, and then we didn't have enough post-interview information. So we decided to stick with just the 1 year period, which was this year, because we had good information for the interviews that they did just like a couple weeks ago.
Yeah, so we'll get into our results.
So we started off with the boosted tree model. So this is more like, obviously, it's like a black box. You don't really know what goes into this as much. It's a lot of math that goes into it. So it would create good prediction formulas for how likely is this match going to work. So we started this off with, are they going to stay with the program? So this is something that would be a lot more reproducible, because we could just hand that formula, looking at if they keep the same data for applications. If they keep that similar, we could give them this math formula. You don't even need to know how it works. You know how it works, but it gives accurate results. So looking at the confusion matrix, so this is the actual, and this is the predicted, and this is our validation set. So we didn't predict all the no's. We predicted 100% accuracy for the 10 out of 10, and then we did predict 3 incorrect for yeses. We said that there would be a no. So it is a little more of a conservative type of model for predicting if they're going to stay with the program.
And then something cool about the models is that we can save our prediction columns, and then if Linda wants to input the students' data and the mentors' data into the prediction, it'll just come out with, our predicted result if they're gonna stay in the mentorship or not.
Now, like for this one, like it's just more likely to be no, 0.7, and then this is more likely yes, so it's just gonna go with it's probably a no.
Mhm.
Next, we ran a decision tree to see if the student will stay with the program. So this is less of a black box model because we can see, like what the model split on, basically. So we can see students with a high GPA above 2.85 will be more likely to stay with the program, and then less than 2.5, you go off to the right. And then depending on the major, the mentee's major, over here we'll have like, it's split between staying with the program and not. So majors like analytics, accounting and finance and analytics, marketing and HR. So that's split between if they're gonna stay or not, and then all the other majors will not stay with the mentorship. And then this is just our ROC curve, so this tells us how well our model is able to distinguish between a yes or a no, meaning if they're gonna stay with the program or no.
So this one was if they're gonna stay with their mentor after we've already decided that they are sticking with the program and they're eligible. So this is kind of like a final, more in-depth view. So blue would be yes, no would be red. So as you can see, a lot of people didn't decide to stay with their mentor. So the first breakdown is current GPAs, 3.4 and above is a lot more likely. There's a lot more of the blue there versus everything below a 3.4 GPA, no, not a single person stayed with their mentor. So that's a very big data point there to think about with GPAs. And then of those who do have above a 3.4 GPA, this is for the mentor's career field. So those in communications, consulting, human resources, and marketing, of those, 5 of them all decided to stay with, the mentees decided to stay with that mentor. For these ones, for accounting, sales, management, and finance, it was split, so less likely. So it's kind of interesting to think, I guess that's something that we can consider, like communications, HR people are more likely to stick with it, maybe that's more beneficial for them, versus maybe people in here are maybe a bit more picky with what they decide.
So that isn't if the candidate matches the mentor, that's just the mentor's field that they're in.
Yes.
Not whether the student and the mentor both share analytics or both share finance.
Yeah, we found that this is the most accurate predictor actually. Matching was like, yeah, it was more about finding, when we have that final result, do they stay with it or not? This was the most accurate predictor. It wasn't really based on the matching, it was just based on the demographics of one of them.
Weird.
Yeah.
Is that weird? Or doesn't that feel weird?
Well, it's like people who want a mentor in finance are less likely to stick with it versus someone who's looking for an HR mentor. If you're looking for an HR mentor and you get one, you're gonna be more likely to stay with them.
Well, that would have been if you have a match. This is just saying,
This is looking at past data and what happened, and then creating a model for the future.
but all this is saying, like I wouldn't have to be in HR, right? I could be in analytics, and if I got matched with someone with HR, then I'm staying with that person. Isn't that what you said there? It is not about the match. It's purely about the career field of what the mentor.
Yes, you would also have to incorporate how these are made. Like, I'm not going to get an HR mentor because I'm not in HR.
Okay.
So
I guess the assumption is that these are matches where there's an HR person with an HR mentor.
Yeah.
Okay.
Yeah, I mean, you would have to see how does Lydia even make. We don't even know how Lydia makes decisions because she's just the one who does it. She kind of looks at it. So this is just purely based on her approach. How successful is her approach? I guess. So, I mean, yeah, it is interesting to think like this is irrelevant for me thinking about me being. I'm not in HR, so I wouldn't even be on that side. But I do have a GPA, so this would be interesting to see how likely just based on that.
Right.
This was the high level. This gets more in the weeds. So using 2 examples to kind of walk you through the model, we have Austin first. So he was in the program his sophomore year and decided to not stay with the program and not stay with the mentor. So with his GPA that he's told me,
And
he would not stay with-
FERPA-wise, he signed off FERPA-wise that he was okay
he
with you
consented to
sharing.
this, so
All right.
with his current GPA of 1.9, he would not have been with the program. So he actually matched our data very well, kind of walking together. Using Dylan as an example, he has a GPA above 3.4. So he would first go on this side. Now we don't know, is he going to stay with it or not? We have to keep going. He did have a finance mentor, so he decided to stay. And that is more likely of a no. And he also did decide to stay with the program. That kind of shows kind of walking through with those two. And then actually looking at the results, it was a 0.8, so this was a little bit less accurate than predicting if they would stay with it. It's harder to predict once they stay with it, if they're going to stay with the mentor. That kind of goes into what you're saying. Like there's a lot of relationship stuff that goes in play there. It's a lot easier just to like keep them in the program and see, looking at the mentee stuff with that. So we had a 0.8 with this. We maybe could have gone a little overfitting with that because 0.89 is pretty high for training data, and there's a big difference there. But that's just kind of the best that we found. And yeah, just a disclaimer here. We did use limited data. This is only for this one school year based on what we had. So obviously it's not gonna be perfect, but just what we had.
So going into our recommendations for Linda and Bethel is continue to value high GPAs when you're matching. Know that those graduating early might not reapply to the program. Matching majors that are significant, so either on the mentor side, and then
for the last one, keeping more data on the follow-up. That's kind of our limiting factor, was we didn't have enough of that post-interview information, which is our why variable, which is the most important. So we had a lot of information on the interviews beforehand, but she just kind of, we only recently got the data for that. So that was something that we'd value a lot, making sure you get that data of how the mentorship works.
And what would you suggest there? Like just a survey of, hey, I had a great match? Because I might choose, I think we decided before was, if I choose not to do it again, there's a whole host of reasons why I might do that, not solely that, oh, I got matched with the wrong person.
Yeah.
If I continue to do it and to stay with the same mentor, it's pretty high likelihood that I had a good match.
Yeah.
But otherwise, it's really hard to determine, what happened.
Mm-hmm.
So you would have a survey.
Well, she already does that. So this last year was really good.
Okay,
So
so you
last
did
year
it.
was the best data we've had. It was perfect.
Was that the only time you had a survey with the results of the?
In the past, she had done everything. We didn't get information. We didn't get that last question of, are they staying? We only would get, are they with their mentor?
Okay.
I think.
Not.
In the past. So it kind of was like hard to know, like, just with their, like, there could be a million, they could be graduating, so we wouldn't even know if that's even.
Right.
So, but what she did this last year was good.
Okay, so continue what she did last year would be a recommendation.
So then the problems we encountered when going through this process, getting the data, like we only had a limited Excel sheet to go into jump, so just getting more data would have been more useful. Linda really likes the open text fields, so since she's a human, she gets to read those, but for automation and how we went about it was not very useful because we didn't do text mining in it.
I thought that Mudak taught you how to do that. What happened?
Yeah.
I think if I show this to Jacob, is he gonna have me?
You might be like, well, I don't know if I taught him anything.
So would there have been approaches from Mudak that you could have done if you had more time to do that, or
If
do you
we had
think?
more than 70 rows, yeah. But
Okay.
it's going to text mining with that. It's just like so subjective. I feel like.
I think they could have been, yeah. And then we didn't talk with Linda about what she thought were successful matches. We just went based on those 3 columns that we talked about. And then this process isn't really automated, but we can get like those prediction columns. She can fill in those fields to see if the matches are gonna be successful or not. But she has to go input them herself.
And what does that look like to input them herself? What is that? I mean, describe what that process would be
So-
for you to continue to pass this on to someone else. What would that look like?
We just have to send her the jump file we made with the model, and then she would have to have jump one computer, or she could just use the computers in the classroom. And then when she gets the information from, let's say, the applications,
Mhm.
she just implements them into like all our columns, and then at the very last, in the very last rows, there'll be that like yes, no to see it.
And how is your data formatted in a mentor table and a mentee table and a match table?
Or it's all in the same
All in-
spreadsheet, yeah.
Okay, so there's one big spreadsheet with the mentor, the mentee, and then the mentor and the mentee are in the same column, and their data's in that column.
Mhm.
That was also, that's the thing too, it would,
So you have to transpose the data each time from the two Google Sheets to
because there was the
run
three,
this.
there was the three, there's a mentor, then the mentee, and then the matches, so we put it mentor, mentee, and the matches, all in one sheet. So she would have to put that all in, there'd probably be some little difficulty, she would have to know kind of a lot of the Excel stuff. She would also have
Well,
to
what Excel stuff would she need to know if you? Yeah.
just making sure that everything's like the right, like even if it's like a date, it's still a date, making sure things like that, making sure that the rows, all columns all match up.
Is the match the mentor name and the mentee name?
Yes, we use name,
Name. So and first name and last name,
yeah, combined.
and it's combined, first and last. So, and then in the other sheets, do you have first name and last name in each of those?
I deleted them.
But I mean, if you wanted to automate this for you, and this is for everyone here, would there be a way to?
We used the Power Queries, that's what we actually used.
Okay.
We used the full, yeah, each one had first name, one field, last name, second field. We made like a match to combine them, and that was our key ID.
Okay.
Primary ID.
Yeah, index match, XLOOKUP, something like that. You could have used to combine the data, or you did use, or Power Query to do that.
But yeah, even with that, like once we get that, she would need how to know how to copy that in a jump, and we would have to walk.
Could you quickly create a video of that process? I'm not saying that she's going to accept it, but would it be easy to do? I'm not.
It's hard for me to know because I've only jumped for 2 whole classes now, so I think I could. It seems self-explanatory, but I understand maybe if it's fully new, jumps different. No one uses jump.
Right.
So.
Does your data is your data in their format, or do you have different sheets?
I bet it's in a slightly different format than they have.
Yeah.
I was just curious if we could do the opposite. If you could predict based on their recommendations,
Oh.
what is the likelihood that they will remain a match?
Yeah, that'd be cool.
Would that be cool?
Yeah.
That would be.
And then
Take more than 15 minutes, but
Maybe 20.
you could create a video of mangling the data to do that. No, you don't have to do that. But I would be intrigued. I would be intrigued if both of you kind of swapped and found out what the results would be. What does ChatGPT think it is, or Perplexity, and then what does your model say the likelihood? And I would hope, what would you hope would happen from your model?
I hope that it works, that it lasts.
But what do you think? I mean, likely if you take that model you had on that presentation.
People below 0.4 are destined for failure.
Right, I would hope that the top ones would say, yeah, they're gonna succeed, and then eventually they wouldn't, but the finding of GPA, like, maybe, like, that's intriguing.
That was not as weighted in ours, so
Right.
it actually might have, I think we might have completely ignored it.
Both of us are exceptions to that.
I mean, it's still interesting. We do completely different ways to approach it.
Yeah,
Yeah.
yeah. So it'd be interesting to see if, what happens if you, and maybe there's a way to approach it that incorporates both the things, and so maybe next year we have to use this as input to the project.
Yeah.
All right, any other questions? All right, let's give it in.